Every corner of the globe is inhabited by life, from the frigid poles to the deepest depths of the ocean, and from the wet tropics to the dry savannas. In fact, if you looked around us today, you would see an astounding diversity of both biological and non-biological forms. From seaweeds to minerals, our world is an astonishing and unique collection of species. In fact, scientists estimate that there are about 9 million species on Earth, and these include species that belong to bacteria, plants, invertebrates, and vertebrates, such as the giant blue whale. Scientists also estimate that about 99% of biological species are extinct. That means that they no longer exist on this Earth. And these include recently extinct forms such as the dodo, and species that went extinct in the deeper past, like tyrannosaurs. And in fact, we only know a small fraction of the biological species that exist today and in our past. And so our picture of the biological world is therefore woefully incomplete. Similar to the biological world, there are about 5,300 known mineral species. These are minerals with unique chemical compositions and crystal structures, and include common minerals such as aluminum and those with scientific and economic value. And like the biological world, scientists believe that the Earth has a unique mineral composition in the cosmos. They're estimated to be about 1,500 unknown mineral species with unique compositions on Earth waiting to be discovered. Why do humans need to discover new species? At the simplest level, humans identify and categorize things around them. This is the fact that spans global cultures from the European schemes to those of the indigenous peoples of the globe. Discovering and classifying organisms helps us to understand the patterns and processes of evolution. Which species share common ancestors? When and why did these new species appear? What factors have shaped the tree of life? In addition to that, identifying and cataloging new species helps us understand where they live. We can then understand the rules that define where species live and how historical events, such as the movement of the continents, still shape diversity today. In addition to that, identifying species as the fundamental ecological units allows us to understand the roles they play in ecosystems, such as how different species play different roles in the cycling of nutrients within and between ecosystems. We can also use the identification of species as indicators of environmental health. For example, the presence of certain invertebrates are informative of water conditions, and things like lichens, moss, and liverworts can be used to directly monitor pollution and environmental health. Similarly, discovering and describing mineral species helps us reach back in time to understand the formation and the evolution of the universe, as well as the makeup of terrestrial objects. Studying the characteristics of mineral species can help us to understand where they formed and the conditions that led to their formation, such as the heat and pressure that occurs deep beneath the Earth's surface. Well, where do natural history museums come into all of this? Natural history museums are archives of biological and mineral species that serve as scientific libraries of the world. They're part of global networks of biodiversity data that play key roles, and in fact, maybe the most important role in the things that I just spoke about. They house historical specimens that contain secrets about world past. They record rare species, and they are sources of irreplaceable morphological and genetic data. Now, natural history museums are not static. They're dynamic. They're always being grown and updated. Our scientists at the Museum of Nature bring in hundreds of new specimens every year, expanding our knowledge of species new to science, where known species live, and previously unknown genetic diversity, among other things. The Beatty Center for Species Discovery at the CMN positions the museum as a leader in the study and discovery of species, their evolution, and their ecology, seeking to transform the understanding of the importance of species discovery. It also centers the museum as a leader in the sharing of knowledge and data on species discovery, as well as a collaborator and partner with institutions around the world, such as through GBIF. With that, I want to welcome you all to our annual Ignite session, and I hope that you enjoy the upcoming presentations and are inspired to love and respect the species around you.